Hello, everybody. Welcome back to the Elastic Live user group where this is a lesson in learning where I, your host, Jay Miller, usually have some type of Elastic professional here. And we are diving deep into something in the tech space or in the Elastic space. And in this case, it's definitely going to be the latter. With me, I have my colleague, which is great because I've seen him twice now today, which is awesome, more than usual. But Alexander Rielson, who is one of the senior advocates here on our team. Alex, how's it going?
Yeah, all good. Thank you.
So we're going to be talking about Spring Data. I know literally nothing about Spring Data, so uh, a lot of questions coming from me, a lot of answers coming from Alex. I feel like we've had conversations like this in Zoom calls before. But before we jump into that and we get to know a little bit more about Alex and kind of his background, I want to remind everybody that, as always, if you have questions, feel free to ask them. It's an AMA. So now is the time. If we can't get to it, or maybe it's not the best place for this question, feel free to throw it into our Discuss channel, join the community, hang out with us there, ask questions, answer questions. A lot of people will be looking forward to connecting and learning from you. And then also, you can, again, join our community. You can check out the community page. We have plenty of events happening. I think there have been like 3 live streams from Elastic just today, and it may not even be the last one. So always be on the lookout for what's happening in your area, in your region, and online on the channel. And of course, if you like the content, give us a comment, give us a thumbs up, like, subscribe, do all those things that we do on YouTube that we talk about. But it really does tell us what kind of content we want to bring to the channel. So that said, Alex, let's start with like, what is your history with Elastic and the Elastic Stack? And I'm gonna full screen you so you don't have to look at me moving around acting all wild.
Sure. Yeah, I think I have quite a long history actually with Elasticsearch. I think it almost ties back a little more than 10 years now. I started with Elasticsearch like back in the 014, 015 days as a product search engine at my previous employer, and like our basic task was creating a product search engine for a ton of e-commerce products. Like so, my previous employer was a B2B marketplace in a specific vertical for hotels and restaurants. And so we were basically the platform, and we had buyers and sellers on that platform. And this means we just had a ton of articles that needed to be searchable. And yeah, my task was to figure out what kind of search engine we can use. And we were a Java shop, so we tried out Lucene, we tried out Solar, we tried out Elasticsearch, and I was pretty impressed already 10 years back that it took me like 20 minutes to index all of our products into Elasticsearch, get up and running, and fire up my first search. And this is how everything started for me. So I slowly started building this product search engine. I kind of figured out all the hated parts of German search. Like German is a tough language if you want to implement a good product search. Not saying that English is easy, but it's just a different beast. Both of them are Western languages, which again simplify things a lot. So we started with this, we improved, we had a ton of iterations. We had different ideas of how to score products, like boosting them by the provision we get, boosting them by their recency, making sure you only find products that are actually in stock, or figuring out certain combinations to save shipping costs, all this kind of things. Many of those things were reflected in the search engine itself, having a mechanism to keep it up to date. And yeah, that's basically how I started. And at some point, Elastic, or back then Elasticsearch, the company was founded in 2012. I joined, I think, a year later or something like that, and was part of the Elasticsearch team for quite some time, 6 years. The alerting capabilities was something I took a lot of work on, or the switch from Joda to Java time. And then already 2.5 years ago, I joined the community team in the hopes of like going back to what I was doing earlier when I started at Elastic, like giving a lot of talks, going to more conferences, which of course in the last 18 months has been not too successful at this point. But yeah, I still create a lot of content around Elasticsearch, and I still do a lot of Java development. And this is also how we're basically getting back to this talk today, where I would like to talk about Spring Data Elasticsearch, which basically is the implementation of Spring Data for Elasticsearch. So how to store data within Elasticsearch using the Spring Data abstractions. And yeah, that will basically get us through the next hour, I guess.
Awesome. And I don't think I've actually heard that story, so I'm glad I got to learn a little bit more about your journey. And uh, also coming from an e-commerce background, I know the struggles of dealing with relevance and what customers need versus what companies might want or need. But yeah, let's jump into Spring Data. So I know, again, nothing. So I'm gonna let you take the wheel and walk me through this, and I will have questions. And of course, anyone in the chat that has questions, feel free to ask as well.
Yeah, I think that's the most important part. Just drop any question into the chat so we can work on it immediately. I don't think it makes a ton of sense to like wait till the end and like follow my monologue, even if I would have covered it 2 slides away or anything like that. So whenever there's the slightest thing of a question popping up, make sure you put it in the chat. And if you have questions afterward, I think Jay already mentioned Discuss, but you can also just drop a comment on the YouTube channel, and I will definitely take a look later at that one. So let me figure out the high tech over here and share my screen. I think that has worked. So I have a couple of slides, not too many. I just want to make sure that we basically share the same foundations. And the other important part is I have a fair share of links there, so I will share the slides later on. We can also take a look at 2 projects written in Spring Boot in the IDE later on, depending on what you're after. And just to get you started, I think the first thing is in the Java ecosystem, whenever you write web applications, like the elephant in the room is Spring and Spring Boot nowadays. I think it's like with all the surveys, you always figure out that 2/3 or 3/4 or even more than 80% are using Spring Boot to write their web applications. And this naturally makes it the number 1 application to store data as well, because like most of the web applications, of course, are storing data. And one of the abstractions in there is called Spring Data. And the plan of Spring Data over here is basically to have kind of a consistent programming model no matter what the underlying data store is. So this could be Elasticsearch, but of course the most common one probably will be a SQL-based database using a JPA or JDBC. There's quite a bit of other implementations, and you can see already at this list here, there's MongoDB, there's Cassandra, there's Redis, there's LDAP. Those implementations are vastly different in their nature. They are very different in how they store data. They're extremely different in how to query data. And they're also very different with their distributed capabilities. And in the best case, this is all abstracted away within Spring Data. So you basically just design your POJOs, your plain old Java objects, you set the right annotations, and everything works.
So one of the I do. So you mentioned kind of and this is me not being too familiar with Java, but you mentioned like Spring Boot being kind of the web framework here, and then Spring Data being kind of the data implementation layer and like the connection to databases. Is this something that's only available within Spring Boot, or can you take this like outside of the web and create kind of a data layer for other applications or like backend or API based applications?
So you totally could do that. I've rarely seen it, for example, used in command line applications, even though it is possible, but it's pretty common for API or other backend applications there. It's not just web applications. So that's a pretty common thing. But most of the time, like Spring Data is just coupled to the Spring framework itself. I've never seen it being used without the other one, to be honest.
Okay, that makes sense.
So, yeah, regarding the different data stores, there's also something called community implementations, which are basically not initially written by the Spring Data team. The Spring Data team is completely or pretty much completely employed by Pivotal, as far as I know. And they basically have also community implementations where the vendors of the specific database implemented. For Elasticsearch, a complete third party basically built the initial version, but it's nowadays also maintained partially by the Spring Data team, and it gets released with every release. So most of the time the Elasticsearch party is up to date. So what does this give us, right? We have this abstraction layer which kind of hides the complexity of the underlying implementation of the underlying data store. And we will see in a couple of minutes that this has advantages and also disadvantages. So just to be something aware, and the common base of Spring Data is basically that you have a so-called template helper class. So could be an Elasticsearch template or a JDBC template for SQL access, which kind of is a helper class to execute queries, retrieve data, and so forth. And this is kind of where everything else is based around. It's a pretty old concept within the Spring framework. And so the Spring Data part just took this and extended this for all the different data stores. And the other interesting part here probably is the object mapping. So you can define your classes, you annotate your classes with metadata. You say like this Java object should be mapped to this Elasticsearch index. This Java field within my object should be mapped to the ID and so forth. And this field should be a date, this field should be a keyword. So kind of the regular mapping tasks that you do with Elasticsearch. This can all be configured via annotations. And the third interesting part of Spring Data are so-called repositories, where you don't write any concrete implementations. You just create an interface. And based on this interface, basically Spring Data introspects the name and fields of the methods you write. And we will see an example in a couple of minutes. And out of that, it generates a query. So you just have to write the correct name of a method. And we will see in a second how that looks like. And those concepts basically exist for all of the different Spring Data implementations, no matter if it's for Elasticsearch or another data store, but each of them has their concrete implementation. And yeah, to make this a little less confusing, let's just go on with an example. So I have a product class over here. You can see at the top that I index it into the products index. Again, as usual with Elasticsearch, you may want to have an alias named product that really points to a different index. So you could change the sharding strategy and things like that, but that is purely optional. And then you could also just define the different fields and their types, right? Just because something is a string doesn't mean that it has the same type in Elasticsearch. Something could be a text, so it's searchable via a full text query, via a match query, for example. But things like tags are usually used for filtering, so it might be sufficient if this is a keyword. You can also change the field name that is used in Elasticsearch. Again, this is sometimes a little complex because users of Elasticsearch often prefer this kind of snake case, where Java developers usually prefer camel case. So you have to make sure that everything is consistent no matter how you serialize your data in JSON. Because what happens internally is Spring Data takes this POJO and creates JSON out of it and then sends this JSON to Elasticsearch in order to store it. And what you basically do here is you just create some rules how this JSON serialization should look like and how the index mapping should look like. And the last part here is the date type. There are a couple more types. Every type you have available in Elasticsearch can also be used within Spring Data. It could be a geoshape or a geopoint. Could be like a ranked distance field, something like that, or a vector field. So all of those fields are available, but by default, I think those are the more common ones you would use. So everything I show here tries to reduce the examples to kind of a minimum thing.
So one of the questions that I know a lot of beginners will ask is if Elasticsearch is like REST API driven and we could just provide, JSON into a body and make a request, why do we need to define a class around the object? Can you speak to that just a little bit? I know it's kind of a generic question, but it tends to be one that a lot of folks that might be learning about Elasticsearch and especially with Spring Data for the first time may ask.
Yeah, I think the idea is actually vice versa, because the question is, like, should you really care what you end up with? Because you ask from an Elasticsearch perspective, but the question, if you're a user of something like a Spring framework, is like, what do I do with my data if I have this in this product class and I have my new product, I don't know, maybe a TV or something like that? Like, how do I store it? And then the question is, do I really have to take care of serializing it into JSON, storing it in Elasticsearch, making sure the write is successful? Or do I just call a single method in my code, and if it doesn't work, I get an exception and I can react on this exception in the programming language of my choice without having to care for all the complex backend parts in there? And I think this is how most of this object mapping frameworks actually make more sense. Like, you think of this from your programming language and you try to abstract the fact or hide the fact how complex storing a piece of data is, right? From a user perspective, you just want to call a single method, save this product in my database, get a successful response if it was if it has been saved, and that's about it, right? You don't want to care for serialization. You don't want to care for maybe a network outage, so it gets retried automatically. And that's my take on it. Of course, from an Elasticsearch perspective, you're like, yeah, but I could just send a byte array and be happy with this. And that's completely fine. But the whole idea of this idea basically here with this object mapping approach is like hide all the complexity that users may not want to deal with. Because from a user perspective, I have my e-commerce shop and I want to store a product, and that's it. And the rest is just an implementation detail.
That makes a lot of sense. And that definitely plays in part to my, like, working with Elastic and for Elastic. I'm thinking about, like, I have Elastic on the brain and doing it the quote unquote Elastic way for all the different languages. But, these tools are often for people who they only go in to talk about Elastic when they have an exact, like, I need to make this thing happen. So us being able to speak their language instead of forcing them to speak ours is, and, as much as possible, is always a benefit there.
Yes, I think you mentioned it at the beginning with the Elasticsearch clients. This is exactly what they do, right? They mimic the behavior of the programming language and make it as easy as possible. And this is basically even on top of the Elasticsearch client in Java to make it even easier for the user of this specific framework, which is Spring in this example, to just like adhere to the standard that this framework is basically setting.
Makes sense.
All right, so this is how like our entities can look like, with the different annotations telling where they should be stored, what is the unique identifier, and so forth. The other part of this is like, what part of my code do I have to call to actually interact with those? How to fetch data from Elasticsearch, how to store data in Elasticsearch, how to retrieve data, how to query for data, right? And this is the interesting part. And this is where Spring Data has a so-called mechanism called repositories. Again, those are completely independent from the Elasticsearch implementation. It's really just about retrieving data. And I said at the beginning that you can basically write your method names in those repositories, and they are basically reflected of what they search for. So if I use this kind of method, find by name and price, the repository automatically figures out, okay, I have to search in the name and in the price field of my documents. So you don't have to write any fancy query in Elasticsearch itself. This is pretty much all you have to identify. And you can change the names of those methods and write find by price greater than, and then this query automatically changes so that you will basically have a greater than query for the price field. This is really an interesting mechanism because it allows you to be really quick in writing your queries, again, without touching anything Elasticsearch specific. You can like completely circumvent that if you want, but it comes with a cost. And the cost is that this very generic mechanism of querying is maybe not the most performant one. For example, there are certain queries that are named like find by name ending with. So you're searching something where the name ends with foo or what have you, or starting with, or where it's somewhere in between. And if you take a look at those queries in the Spring Data documentation, you see that they're not written efficiently. They are written in the most simple way that they will always work. But if you would run this against a lot of data, like, I don't know, several millions, tens of millions, depending on how you run this query, it would be slow. And this is not the fault of the repository here or of Spring Data. It's just something that you could make more efficient by changing your Elasticsearch mapping, by writing the query a little differently, but you would need to do changes first. And this is just something I want to make sure everyone is aware of. Just because you have this extremely nice method that you only have to define once and then you can always use them, doesn't mean that it's always the best way to do it. And it's something to keep in mind when you use those generic tools like repositories in Spring and Spring Data to make this work. And this is also not something that just applies to Elasticsearch, that also applies to other SQL queries, right? When you have different types of indices and you can make your queries or optimize your queries, you sometimes have to change the structure of your queries. It's just the nature of many, many data stores out there. Just to be sure that people are aware of what I mean with repositories from a coding perspective. If you want to use one of those repositories, all you have to do in your code is basically write these 2 lines of code. And what this means is you would like to create a so-called user profile repository, which you can then use in your code. And this one basically fetches user profile entities. So this could, I don't know, maybe the profile of a user that is logged in GitHub, for example. You would see like, this is my username, this is my email address, this is my avatar picture, things like that. And you would just have some generic methods available to store data, to find data, to load data by its ID, because you still have this unique identifier, the ID in Elasticsearch. In other data stores, this could also be a long, for example, but in Elasticsearch, it's always a string, this unique identifier. And with this, you basically have the basic CRUD operations, as they are often called, create, read, update, and delete, immediately available. Plus, if you would like to have your custom finder methods like this, you would just define it as part of this repository. Again, only specifying the method name here, because this is an interface in Java. You don't need to write any implementation code. You don't need to write anything with the Elasticsearch client in mind. You just can go up and running, call this method, and find all your products based on the name and the price if you add it within this interface class. And this is one of the strengths of Spring Data, that it automatically translates those methods names into fully fledged Elasticsearch queries without you having to do anything. It's really, you stay in your Java world as far and as long as possible at this stage.
I can't wait to see a demo of this, because it feels so magic. It feels like there's a lot of stuff happening behind the scenes, but
yes,
I'm definitely looking forward to seeing that.
That's a feature of Spring itself. This is one of the strengths of Spring and Spring Data, that like you just don't have to do anything. Like what happens here is when the Spring framework, the Java program starts, it kind of searches for any classes that extend Elasticsearch repository. Then they figure out, okay, it wants to load user profiles. What's the next step? It looks up the index in here. It looks up the ID in here, which field is set, and it magically basically introspects your Java classes and then figures out everything that needs to be done. And that's one of the strengths of Java here, that it's really easy to do that from an implementation perspective, so that you can go fully dynamic, and that it's really easy on the user side of things, right? I don't have to write a lot of boilerplate code to get up and running. I can, and we will see in a minute that there are stages where it makes sense. But if I just want to have like my simple application to save and store user profiles, then this is all I need to do. And as usual, then this is another strength of Spring Data. It allows you to use all the power of the underlying database technology, but you don't have to. In this example, I use the so-called reactive repository. Reactive in this context means that it's basically using the reactive streams implementation and nomenclature. Like this is a flux here, means that this is not a list of products, but a stream of products being returned, and it's basically non-blocking. Okay, I see there's not a question, but a really nice comment. Thanks for that. So if we continue here, you can see that I implemented a custom method, find products. This one will not be automatically extended, so it will not search in the products name field or anything like that, but it will use this JSON query to actually execute my query. And this is a two-folded query. We have a multi-match query first. We are searching in the description, name, and tags fields for the string that is supplied here. However, we also add a so-called should clause. You may know this from the bool query, that when you add a should clause, if this query here matches a document, the score of this document basically becomes higher than the same document which would not match this query. So you can kind of do ranking. And this is the nice part about a data store like Elasticsearch, right? The definition of relevance and what is more important is way more flexible with a search engine than with most other data stores in here. And in this example, I just said like, look, I want to find a product, but if the product, if what I'm searching for occurs in the name field, then I would consider this product more important than something that is maybe just in the description or in the tags. And yeah, everything here is JSON. This comes also with a problem, because you have to make sure that this is actually valid JSON. Like if I miss this tiny little comma over here at the end, like this query would fail. And this means like if you use this query mechanism, and there are different mechanisms that you can use, this is just an example, you have to make sure you test this, right? Because it would be a real shame that you write your fanciest query here ever, then you fire up your product, you deploy it to production, and the query fails, just with a big bad exception. So this is something that is only basically executed at runtime and not at compile or build time, which means you have to write proper tests for it. Okay, so we're slowly like going more into the Spring side of things, because at some point you also want to know like how this gets used. I'm again just using the reactive repositories as an example. Don't worry, I have a GitHub link at the end which contains all of this, so you can just run it by yourself if you want. But the basic idea here is, because you're using reactive repositories, you can just run this piece of code. It returns a mono product, so a single product in the reactive way, and that one is returned as JSON back to the caller. Yeah, you could also go with a regular blocking repository, then it would just return a product instead of a mono product, but just block the thread until the data is fetched. Yeah, we could delete a product over here, and of course, because we implemented our fancy find products method here, we also implement a custom endpoint to actually search for data. And you would see like this would look very similar to like an Elasticsearch request. You just call a search endpoint, you specify a request parameter named Q, like right after here, with a question mark Q equals whatever, and then you could search across the products and they would be returned again as JSON. Okay, so that was the kind of reactive introduction, but of course this is not everything. Again, the strength of this is that you do not have to deal with anything Elasticsearch specific. The weakness of this is that you cannot really fully customize the queries you would like to customize them. Like Elasticsearch has so much more power than search power and different kind of search queries than what we just saw with the different finder methods in the Spring Data repositories. So you can always go back and basically write the queries the way you would write them in Java with the Java client that is written on the Elasticsearch side, and then just execute this. And the way this works is that in this example, we could write a query which is a bool query that contains 3 term queries. So we search for the URL, the submitted address, and the category. And then we just use the Elasticsearch REST template. And we return this data. In this example, I return a contribution class. And so I'm searching for a single contribution class. As you can see here, that's a search one method. So only a single entity gets returned. Yeah, we get to the Elasticsearch Java client at the end, because that's not the one that is used here at the moment. Because right now we are kind of in a in-between state where we have 2 different clients for Java, but I will get to that at the end.
Okay, I jumped the gun on that one, my bad.
Absolutely. No worries, it's all planned for. It's good. Okay, the basic idea here is that you basically have the possibility to write a so-called native search query. And that is one of the interesting aspects of the Spring Data implementation, that you can always fall back to the native capabilities of your tooling, right? If I have a data store that uses different queries to retrieve data faster, more efficient, or I'm, as a Java developer who has used Elasticsearch for ages, is just more used of writing this style of queries compared to using the Spring Data mechanisms, then I can just fall back to that, and I can be happy by just supplying this native Elasticsearch query to my methods and get back the data I need, and that is really useful. Like this example is slightly artificial, but this gets more interesting the moment we basically also use aggregations, right? So we can not only return entities like my product, but I can also write a query which on the one hand receives entities, but on the other hand also receives aggregations that I may want to return in my data.
So it's like let Spring and like the basic functionality of Spring handle a lot of those common use cases, but then when you need to start specifying anything and like, you know, going into the details or optimizing, that's when you may reach for kind of the Java REST client and the functionality within there.
Exactly. You basically always have the export mode available without being forced to use it. And that's one of the nice features of those Elasticsearch template classes, which is there, but there's no need to actually fall back to it.
And that's probably good for people that are, if you just need to get like, hey, my company has Elasticsearch running. I'm not too familiar with Elasticsearch. I need to get some basic search functionality working. Spring is there. And then as you over time develop more and more knowledge around the Elasticsearch API, you can start to figure out how to optimize those searches. And once you exceed the benefits, that's when you reach for the REST client and then go and start doing those optimizations. I like that.
Yeah, and the other part is if you do those optimizations, you can do them like step by step in your code, right? If at some point you figure out you have this single hot path where another query will be more efficient, just replace it over there, but there's no need to rewrite all of your other code, right? You can mix and match using the Elasticsearch template in one part of the code, but using the repositories in another part of the code, and it's not an issue.
And I would guess that in terms of the Spring endpoints that you're using, those are basically optimized. I mean, those are for what you're doing. If you're doing the basic thing, using Spring instead of using the endpoints are probably going to give you more bang, for what you're trying to do, and probably save you a bunch of time also in the process.
Yeah, I think it's not so much about the speed of the implementation, it's more about the speed of the development here, right? Like if you get up and running faster, this is the more important part here than squeezing out the last bit of performance. This is always something you can do as a second step. Like first get the implementation up and running and make your code do what you want it to do, and then optimize.
Cool.
So yeah, this is just like the addition to what we saw on the previous slide, where you can just go more complex with queries. For example, if you would try and write this query as one of your find methods in the repository, it would become really, really long, right? You would be like find by region and state and cycle and not category, and then you have to supply like the 4 different arguments over here. So the method name would become incredibly long. It would be really hard to read. And at some point, like while this repository pattern is good to get started, maybe you should not use it religiously to like come up with method names that are longer than your screen. So at that point, it probably makes sense again to also fall back into the more Java style or this Fluent builder style of the query builder that is already shipped with the Elasticsearch high-level client. And the second part over here is that we can also add aggregations, and this makes it interesting to not only get back my hits, but also the aggregations in the response. So if you have your classic e-commerce use case and you're searching for product, then on the one hand, you would like to display the products, but on the left-hand side, you usually have your facets, right? If you search for TV, you have a facet, maybe the brand, right? There's LG, there's Sony, there's Asus, there's whatever for the TV, and you want to see like how many documents for each of those matched, or you have a list of categories and want to see how many products were in each category. And this requires you to also specify aggregations within your search request, and you can do everything in a single search request instead of sending several, which of course is much faster. And in order to do that, again, you can just write your own aggregations and your sub aggregations. So this one uses a top hits aggregation, so it goes even further than just adding aggregations in the response. It even contains hits in the response, and you will have to pass those and figure out what they are. But you can do all of this because this is again what works with the Elasticsearch client, and this is pretty much fully exposed in Spring Data as well. All we have to do is basically using the Elasticsearch template class here again instead of a repository. So the one thing I just want to make sure that it's clear and mentioned is that Spring Data has another very common mechanism, and this is so-called configuration classes, where you basically configure everything in your code, like you say, my Spring Web application should secure the following URL, so you need to be logged in to do that. So you would configure your HTTP configuration, but you can also configure your Elasticsearch client in there. And on the one hand, this usually makes sense because you would like to configure the URL. You may want to configure the basic auth information. And what I usually do is that I have a single system environment where I read this data from. So you can specify a URL that also contains basic auth data. And in most deployments, you have something like Vault up and running, and then you store this environment variable in Vault, and it gets retrieved by the Docker container, Kubernetes pod, what have you, on startup. So you know that this is available, and then you can just create it. And this is really nice to do because this works when you deploy to production. But you can also have something like a .env file in your local deployment if you test locally and just change the Elasticsearch URL to something like localhost, so you can try to get up and running locally with no issues. And this way, both of this works. So I like to use system or environment variables to configure these kind of things. And yeah, I have a little bit of, excuse me, I have just a little bit of code to make sure that SSL is configured, if HTTPS is specified in the URL, that the basic auth data is extracted. And if I don't specify anything, we could just fall back to localhost. I'm not a big fan of this actually from an implementation perspective, because in your production code, you would never really see if this environment variable actually gets read. It would just fall back to this piece of code, and then you would probably wonder why nothing works when you deploy to production. So I'm usually a bigger fan of checking this environment variable, and if it doesn't exist, stop the startup of your application. Like just crash hard and tell users, look, the setup is not what I expected, instead of having like these kind of defaults here. And by default, for example, the reactive client also is doing this. So it's using localhost as a default. And I think for prod applications, this is not a good option at all from my perspective.
The nice thing about this, though, is it gives you kind of a singular place to make sure things are set up correctly. I know that that's one of the things that I am on record saying that, things like Docker Compose or, Kubernetes, it's great in how helpful they are, but it also like creates another place that I have to check to make sure things are working properly. So being able to say, here is a single point where I can go in terms of Elasticsearch, I don't have to look anywhere else. Here's my configuration. If something is wrong in terms of the setup of it, it's probably in here.
Yes, exactly. That's one of the things I also like. And it's explicit. It's also one of my like philosophies when writing code. I would like to be able to debug it. I would like to be able to set a breakpoint and step debug it in case anything goes wrong. And with this few lines of code, that may not be 100% necessary, but I can still do it. Like it gives me, it's more of my personal safety if you want, but in case something happens, I can debug through it. And that for me is always a really good and important option. Okay, so we're gonna have the Q&A in a second. There are a couple of things I would like to mention. Jay already hinted at the Elasticsearch client, the last link, which is in the chat, the Elasticsearch Java client. So right now, there are basically two clients. The one that is used within Spring Data is the so-called Elasticsearch HLRC, the high-level REST client. The high-level REST client has been around for quite some time. It features all the endpoints. It also features all the builders. Like it's a fully fledged client. One of the problems is it ships with the whole Elasticsearch as a dependency. So the size of this is sizable. Like Elasticsearch itself, I think it's around 32 megabytes. And all of those is basically included as a dependency, as a transitive dependency within the client. And Elasticsearch ships with some dependencies that are very common, like Jackson, Lucene, and a couple more. And this means you have to make sure that within your Java project, everyone has the same dependency, and that rarely happens. The moment you have 3 different dependencies or 3 different versions, you can just hope that there's no backwards breaking compatibility issues in there. and you also don't know which of your dependencies are actually loaded first, right? Like the Java class loader doesn't define a full order on that. So that's a tricky thing to do. And the easiest solution, or the easiest solution from a user perspective, is having an Elasticsearch client that doesn't have an Elasticsearch dependency. The most complex solution from an Elasticsearch developer perspective is, of course, creating a new Elasticsearch client that comes without all of this cruft. However, this is basically what is being done exactly right now. So the first beta version of this is released, and this is what you can basically find in the link that Jay provided. The high-level REST client, the existing one, is basically part of the Elasticsearch source. And the interesting part here is that we basically have a clients initiative where we have a couple of different clients for many languages nowadays, like things like PHP, Python, Ruby, Node, JavaScript, even Perl. And they all basically get their information from a so-called specification. So they kind of figure out that those are the Elasticsearch endpoints that I have to query, and then they can create parts of this client automatically. So whenever there's a new endpoint, you just add it to the specification, and then all of the clients basically have the same feature set in there. And the new Elasticsearch client is also using this infrastructure. It also only uses the Apache HTTP client as dependency. It doesn't need Elasticsearch anymore. You can pretty much pick which JSON serialization mechanism you would like to use. I think out of the box it supports the Jakarta JSON stuff and Jackson. So it's much more lightweight. The whole dependency now is a couple of megabytes. And at some point, Spring Data will also move to this, but the new Elasticsearch of course, client needs to be stable first. And it also brings a couple of new concepts. So when you can't replace your client code one-to-one if you use it, especially if you go with the native code. But that's basically part of switching or getting rid of those dependencies, because all of the classes at some point leak into the Elasticsearch code base and need code from Elasticsearch. And because we don't want that, there will also be backwards incompatibilities, and you will have to replace the code you wrote for things like custom queries. One last thing I want to talk about that is that the new client basically also has the concept of a transport mechanism. And the interesting part here is that once we have connected to an endpoint, we could potentially in the future, just what we do with other clients already, not only talk to Elasticsearch, but also to other parts of the stack, like workplace search, like maybe parts of the observability solution. And all of this will be easier possible with this new concept of transport. So while we will start, or while we have started rewriting this client for Elasticsearch only, that might have not been the last part for all of the clients that we have. They will be able to support all parts of the stack at some point in time, including the Java client. Sorry, go ahead.
You literally took like my question that I had coming up of is there Spring Data for all of the other components in the Elastic Stack like APM and workplace search?
Yeah, so right now there's not, but if at some point this new Elasticsearch client will be adopted, things will be much, much easier to implement these kind of things.
Cool.
Okay, so I have a couple of links that might be interesting. So the first two are basically sample applications. So this one is a Spring Boot reactive application that you can run yourself. Just build it, and there's a jar file that you can use to run. This one is not a reactive, but a blocking application. Basically a small link collector where you can up and download links if you want to. And so you can take a look of how Spring Boot applications are actually written. I've included the reference documentation here. This is an interesting one because it's not only about the application itself you're going to write, but for example also about the logic. And with these dependencies, and I think it's another 1 or 2 line change in the Spring configuration, you can write JSON log files automatically, which basically means you don't have to convert them before you would like to index them into Elasticsearch using Filebeat, for example. Everything is already written out as JSON. An exception is written in a single field instead of parsing any multi-lines. So This will simplify writing log files as JSON, and you will need less CPU parsing data, so that usually is a good alternative. And yeah, if you want to know more about like Spring Data, I also dug up an oldish blog post about that, and I also dug up an oldish blog post about the Elasticsearch REST client. And if at some point the new client is written fine enough, I will definitely write another blog post to make sure how to use this new and newish client. If you want to read a book for Spring Boot and just get up and running, I think Spring Boot Up and Running by Mark Heckler, one of, I think it's a former Pivotal employee. This is a kind of 250, 300 page book to really get up and running. So when you're getting started with Spring Boot, this is quite a good thing. And Hacking with Spring Boot is actually covering the reactive part. So if you need like more of high performance applications where you need to squeeze every bit of performance out of your application at the cost of a slightly more complex programming model, then basically this book is a really good start. But I would highly advise you to not start with reactive Spring Boot, but really with a non-reactive blocking Spring applications. And then if you figure out you need more performance, like go there, go reactive and start with that. All right, so we do have some time for questions, I guess. I can also show certain things in the code. So from now on, like we can go completely freestyle over here.
No, this was absolutely helpful. And I mean, the thing I like about it is the accessibility of not just Spring Boot, but also Elasticsearch using Spring Boot. And I'm going to immediately stop talking because we do have a question. I'm going to throw it up on the screen here from Toby. Is there a way to use an interface as the Pojo? Going to need the acronym for that for Spring Data Elasticsearch repositories by annotating getter methods rather than by annotating concrete fields?
That's a good question. I have to think about it. I suppose you would not only have getter methods, but also at some point implementations. You still have to annotate the concrete implementation on top of my head as well. And I would say on top of my head that it works with abstract classes, but I don't know on top if it works with interfaces here. I would need to look it up.
Okay. What I was saying before with this, and absolutely anybody else, if you have a question or if you have, this is probably a good opportunity if there's something about, Spring Data or Spring Data Elasticsearch is kind of like just not gelling with you. Great time to ask it. Just the accessibility of this, I mentioned at the beginning of this, I am absolutely not a Java developer. I could probably look at this and get a good understanding of what's happening. And I think that's something that as, more and more full stack developers are there, or even backend developers that are having to, program in one language, but also understand and not necessarily destroy things in another. I think tools like this, and the more that we can make tools like this, is always a positive.
Yes, I fully agree. Like the more you go to where the developer is and the less where you have to provide the infrastructure, I think it's a great win. And this is a really good example of not only going through basically doing the first part of it, which is the object mapping itself from a Java object to the JSON object that you want to serialize, but doing so much more around it that it's actually really easy to use for any kind of developer. And then on top of that, using the Spring Data principles, which are very well known throughout most of the Java community, this makes it really easy to get up and running, to get started if you're already familiar with Java, right? The rest is just some glue code and making sure the service is up and running, or using Elastic Cloud as a service to make sure you kind of get up and running as fast as possible.
Cool. Well, while we're waiting to see if any other questions come in, I know that we're using Spring Data for another project that you and some of the other team members are working on, which is the Elastic Bytes. Can you talk a little bit about what you're doing there and kind of some of the topics that you're covering?
Sure. So the basic idea here is, at some point I will be able to type correctly. And the idea of this session is basically, and it's also on YouTube, so there's a dedicated playlist for this. But we have something called the Daily Elastic Byte. As you can see here, it's in the European time zone. So every day before lunch for 3 weeks, we do like kind of a 10-minute session where we cover a different part of Elastic observability. And the basic idea here is like we take an existing application, and in this example, this is our Spring Boot reactive demo here, and add different aspects to it so we can make sure we make this application more observable. So we started with making sure we write JSON logs and we put them into Elasticsearch using Filebeat. We will add APM functionality in the next step. So we kind of monitor the application from the inside instead of just getting data from the outside. And so step by step, we want to make this application as observable as possible without like going super deep or having extremely long sessions. For us, it's really important like to keep this short and concise so people remember, okay, I could do this. And if you want to do more, like just follow the links or the longer talks about the specific topic and see how you can basically work around that. And you can also see the first recordings because there's a dedicated playlist for this. If we take a look at playlists,
we have a lot of playlists.
Daily Elastic Byte, and we can see it down here. We don't do it for the first time, so we have, I think this is the third series of it. So the first two were more about getting up and running with Elastic Stack and with Kibana, and now we take a look at our first solution with all the different aspects, starting with APM, but also talk about OpenTelemetry and distributed traces. Again, for us, it's more important in this series to take a look at where the user is with their existing application instead of starting from the Elastic Stack side and then going from there and telling users, like, this is how you have to modify your application. But like when you have this application, this is what you do to get better insights.
And the fact that you're using it to cover observability really speaks to kind of what I asked with the first question of, obviously you can build a website that presents information and makes it observable, but you often want to visualize this information without making it available to the public. I think that's something that I have a talk somewhere about, of like just building Python Flask applications just for better visibility of the exact information that I need, so that people who aren't necessarily as versed with the Elastic Stack can still see that information, still see those visualizations, and get that information in a format that they're more comfortable with. So I love that not only are we covering something like observability, which is super important, but we're also doing it from the lens of what if you aren't too familiar with, digging into Kibana Lens or doing, all of these TSIB or TSVIB, charts and stuff.
Yes, yeah, that makes a ton of sense. There's one more thing to Toby's question earlier that I just remembered, and there's basically this one class which takes care of converting the POJO to JSON at the end. That is the mapping Elasticsearch converter. And you could always go with your own implementation and basically take care of retrieving the data properly from interfaces and things like that if you really needed to. But I think I would try not to do that in order to not increase the complexity of my application, to be honest. So I would stay simple and first put the annotations right at the fields, but I will definitely take a look and leave a comment on the YouTube video later on regarding that question and see what can be done about it.
Awesome. Well, and of course, if there are any questions after the fact, or if you're watching this video later on, feel free to throw a comment in. We do monitor the comments, and if there's a good question in there, we'll try to get to it as fast as we can. And then, of course, if you have a question that maybe isn't for this, you can always take it to discuss.elastic.co, where we have plenty of questions coming up. And I think we did have a question. Oh, nope, just a thank you from Toby. So Toby, you're very welcome. I know I didn't do anything. That was all Alex. That said, I think that's going to wrap it up for this week's live stream. Alex, as always, thank you so much. You're on Twitter, right? You're on Twitter, you're on social media?
Yes, absolutely. You can just ping me on Twitter if you have further questions over there. You can also just drop me an email. If you have any questions, I'm happy to answer.
Awesome. And just the administrative side, next week we start a 2-week series with Benjamin Trent, who's one of our machine learning engineers, and we're going to be covering machine learning and natural language processing in the Elastic Stack. Again, another topic I am very not familiar with and hope to learn a ton from. So with that being said, thank you everyone for hanging out. If you enjoyed it, be sure to like the video. If you're not yet, be sure to go ahead and subscribe. But until next time, we'll see you next week.
All right.